We'll now begin the third session of today's forum. It is under the theme Future of Shipyard, AI-driven manufacturing innovation. And we are honored to have presentations from Mr. Joe Bohman, CTO of Siemens Digital Industry Software, and Mr. Nicolaus Radford, CEO of Persona AI. And first, we'd like to have Mr. Joe Bohman, CTO of Siemens Digital Industry Software, to take the stage. So ladies and gentlemen, please give him a big round of applause.
Hello, everybody. I'm going to practice my Korean. Hangyeon haseyo. It's okay? I'm super excited to be here to talk about the future of shipbuilding. Once again, I'm Joe Bohman, CTO and Executive Vice President of Siemens Software. And so I wanted to talk a little bit today about our partnership. And I wanted to thank HG Hyundai for our partnership. Our partnership started together several years ago when we started working together on engineering, and we signed an MOU about how we could work together on the future of engineering of shipbuilding, and then we moved into manufacturing, and we worked through the whole process. And I'm very excited now to talk about the future and where we see things going in the future. And so just to introduce Siemens a little bit, I think Siemens is a well-known company. Siemens, we're number one in automation. We're number one in industrial software. And what's our strategy, and what is it that is driving us relative to that? And we're focused on three things, and I think these three things are very appropriate for the conference that we have today. We're focused on the comprehensive digital twin, and I'll show that. And when you think about that, we talked, and the chairman talked a little bit earlier about AI. And I think one of the things that at Siemens that we think a lot about with AI is we think about AI goes together with data. And the comprehensive digital twin of a ship is really about all of that data, and I'll talk about that and how we've put that all together. Life cycle intelligence, that is our word for AI. That is our word for how we're bringing AI into everything that we're doing. And the third thing that we talk about is openness. And I think that it's really critically important in understanding and putting together such a massive undertaking as shipbuilding. There are so many different players, and we're very committed to being an open player in this. We've made a lot of investment in our strategy. We've made a very significant investment in our strategy. We've spent over 25 billion euros bringing together the most comprehensive digital twin, and I'll show that a little bit more carefully and show all the pieces that we've brought together that make this up. I won't go through all of the elements that we brought together, but there are a couple pieces that I think are really relevant for this discussion today. One is Foran. So Foran, a few years ago, we bought Foran, which is a leading provider of shipbuilding software. And we've taken that software and we've integrated with many other of the other pieces that we have as part of our comprehensive digital twin. Some other pieces that we've brought together, we recently acquired Altair, the leading software for simulation, and also some leading capability for data mining with RapidMiner, and I'll talk about what we have with this. And then the other thing I would like to emphasize is that we're not done. We're not done. We continue to build out our comprehensive digital twin, and we continue to make this investment to ensure that we can have a full fidelity of a ship as it's designed and built. We are very focused at Siemens on the shipbuilding industry, and so here you can see we have many different industries that we do target, but the marine industry is an area of tremendous importance for us, and it's an area of tremendous growth. And so I want to talk a little bit about the investments that we're making there and how we're driving this forward. So you might say, hey, Joe, you showed a slide where you've spent a lot of money. That's interesting. But what are you doing to bring all of that investment together, and how are you making all of those pieces work? And we do this through what we call digital threads. And we have 5 digital threads that we focus on that are all about how workflows through marine workflows. And so you can see things around smart shipyards, smart manufacturing, and I'll show that upcoming. And so this is how we bring all of these pieces together with our digital threads. So how are we doing? How are we doing with the marine industry? And I'd say that we're doing very well. We have, here you can see a list of customers that we have across the marine industry. And then also, we're doing very well. We saw earlier the discussion about the navies and the growth of the military shipbuilding. And so I'll just go back, and so you guys can maybe spend a minute and kind of look through all of the different customers. Of course, this is very exciting to us, our ability to go and work with so many different customers in the marine industry. And then here, we'll have a presentation later from Huntington Ingalls, which is one of our partners. And by the way, another company that's not listed here, which we traditionally haven't thought about in the marine industry but presented earlier, is Anduril. And so we are also doing a lot of work with Anduril as they work and build out their business. So we feel and we work with customers facing a tremendous amount of increased complexity that we saw through the presentations that have been given earlier today. We saw discussion about sustainability, efficiency, cost effectiveness, the need to be secure is something that is increasingly important. So there's this variety of challenges that our customers are facing that we would like to help them with. And how do we do that? So we talked about all of these different pieces. How do we bring all of these different pieces together and help our customers? And this is a very important chart for us. So this is a chart that we call our Siemens Marine Strategy, or we could call this, even sometimes we call this our digital thread backbone. And what you see here is you see the flow of information as a ship is being designed and built. So on the left, you see ideation, you see engineering, and all of the work that's being done in the different domains of engineering, mechanical engineering, electrical engineering, simulation, 1D simulation, 3D simulation. And what you have to think about is every one of these engineering domains is generating a tremendous amount of data. And so keep that in mind as you think about AI and what's happening with that. And then one of the things that we're very proud of at Siemens is we're very proud of our ability to take all of that engineering data and feed that to manufacturing. And so on the right of this chart, you see the manufacturing bill of material, the bill of process, all of the things that are happening in the shipyard in order to then manufacture the ship that has been designed on the left. And when we talk to customers, and we talk to many, many customers, they often talk about the difficulty of information going from the left side of this chart to the right side of this chart. And sometimes we see this phrase, and we hear this phrase, what's called human glue. That we actually have customers where they actually have whole departments of people that are just moving data from the left part of this chart to the right part of this chart. And it slows our customers down if they don't have an integrated backbone. So by bringing this all together, we have customers that have reduced their cycle time by 30%. So a 30% cycle time reduction by connecting engineering to manufacturing and making this information flow more easily. And so this is, once again, a very important chart for us. And when you think about all of the investment that we've made building our portfolio, this is a good way to look at it, and this is a good way to understand it. And another thing I would just say for the shipbuilding industry, another investment that we've made on this chart is performance. When we talk to HT Hyundai, I see the chairman nodding his head, yes, is that the ships are big. Ships are very, very large. And we've made a big investment in our portfolio to be able to manage the very large amount of data that is necessary for shipbuilding. So let's take a look at that. And this is a piece of work that we did with NVIDIA. And we continue to work with NVIDIA, by the way. And NVIDIA, their GTC conference, DC, is this week. And our team is there with NVIDIA this week. And we're going to be showing some additional work that we're doing with this. But let's take a look at what this looks like in action. And this is a video that maybe some of you have seen and maybe some of you haven't. But this is where we've taken the Omniverse technology from NVIDIA, and then we've taken that with our accelerator portfolio that we have in Siemens, and we're able to now understand, to be able to see and model a ship in all of its complexity all the way through the cycle. And so what we see here is a model of the ship itself, an ability to be able to fly through the ship and understand all of the structure of the ship, which is an amazing amount of detail that we have in this, to be able to simulate how the ship is going to float through the water and how it's going to be efficient with that. And then actually how to be able to go down into the yard and be able to understand all of the operations that are happening in the yard. And so there's a couple pieces that we have with this. We have something that we call our digital reality viewer that is, once again, built on the NVIDIA technology. And then you will see this week, and you will see upcoming further announcements from Siemens and NVIDIA about how we're taking this Omniverse technology and infusing it into our portfolio to enable shipbuilding. Okay, so with all of that, we've got quite a bit of capability with data. What about AI? A lot of this presentation has been about AI. A lot of this session earlier through the day has been about AI. And so what are we doing with AI? And so I'm going to show a couple examples of how we're bringing AI into our portfolio and infusing it into everything in what we do. And so on the right, you see data. You see the sort of data that we just saw earlier going through the presentation of the boat fly-through. Technology, you see NVIDIA on the left, but you also see OpenAI. You see all the different models that are out there. Across the bottom, you see a variety of technology. Everybody talks about large language models, but there are other technologies that are important for being able to do AI. And then we're able to take all of this technology, put it with our Siemens accelerator portfolio in the middle, and then we're able to start doing AI use cases. And now what I want to do is I want to just show you a few, not all, just a few of the AI use cases that we're building into our portfolio. Let's start with Altair. With Altair, we have a new capability called Physics AI, and it's that box on the upper left. I know there's a lot of words there, but what that says, with Physics AI, we believe that we can make simulation 1,000 times faster. Not 10 times faster, not 100 times faster, 1,000 times faster. And then with that box at the bottom in the middle, RapidMiner. With RapidMiner, we have the ability to take all of that data that we saw and mine it and run AI over top of it. Now, we're working with partners. We're working with partners like Palantir. We're working with partners like Snowflake, partners like Databricks, to be able to take all of that data and understand that and be able to run AI over top of it. So this is an exciting direction that we're heading into. So what are some examples of what we're doing with this? Real-time maintenance with AI visual quality inspection. So we're actually using synthetic data generation and AI systems to be able to do quality inspections of things that are happening in the yard. And so you can go and you can now use AI and get tremendous gains. You can commission things faster and you can do quality inspection much more quickly with this AI capability. The next example I want to show is an example with agents. And there's a lot of discussion about agents. The previous conversation mentioned agents. And what I'm going to show now is I'm going to show an interaction that happens every day and any customer that's doing manufacturing. And that interaction is handling an engineering change request, an ECR. And I'm going to show how an agent can help make that process a lot faster. So let's take a look. On the left, what we see is we see a Kanban board with all the tasks that this manufacturing engineer has. On the right, what we see is a work cell that this engineer is working on, and I'm going to show how an agent can help make that go much faster. So here, the engineer opens up the task that she has. The task says that what you need to do is you need to do this, make this change relative to an engineering change request. So what she does is she assigns it to an agent. We're adding this button all through all of our software where you can assign it to an agent. We have a digital thread agent, looks at it, assigns it to a BOM agent. The BOM agent actually starts processing that change right now. Now, what our engineer can do is say, okay, goes back to continuing to work on her work cell, and she's still working. Look on the left. The agent moves the task from in review, from in progress to in review. But there's a human in the loop, and then she goes and looks at what the agent did and makes sure that that's right. So this is what we think is the future of software design, is that agents are going to be assigned to do these sorts of tasks. There'll be a human in the loop, but that this will take a tremendous amount of time out of the design of engineering tasks. Another example that we have here is we have an example of doing commissioning with, in a factory, and this is with our process Simulate. And you can see, and Nick's going to come up, and Nick's going to talk a little bit about humanoid robots. And you can see that we've already added the capability to our software that designs work cells to understand humanoid robots and understand how those robots can interact with the operations that are being planned out through this manufacturing planning software. So I think another great example of how we're bringing AI into the platform. And here you can see all of the different capabilities that are being offered with this. Okay, and then just a final look at it relative to the agents. We call these digital thread agents, and the idea is that with our digital thread, we can assign work out to different domain agents, and we'll be introducing more and more domain agents, and our digital thread agent will be able to orchestrate work across all of these digital threads. So in summary, once again, thank you to HD Hyundai for the invitation to be here. Very excited to be here. We're very excited about our Siemens Accelerator portfolio. We continue to build it out. We believe it's a great portfolio for doing work relative to shipbuilding and the future of shipbuilding. We have an open innovation strategy. We're excited to partner with HD Hyundai for innovation. And then the third summary comment I would make is the world is changing. And the world needs more ships. And the world needs more ships faster. And we're excited to partner and be part of that. Thank you very much.
Thank you, Mr. Bohman, for your view and perspective of Siemens and also your insights. And next, we'll be moving on to our next presentation. This time, we'd like to invite Mr. Nicolaus Radford, CEO of Persona AI, for the next presentation. Please join me in welcoming, and please give him a big round of applause.
안녕하세요. 감사합니다. I want to express my sincere appreciation and gratitude for being invited to be part of this event. Chairman Ki Sun-chung, 감사합니다. Mr. Lee with HD KOCWE, thank you again. I am looking forward so much to talking about this topic. I think it's one of the most apropos things we can be discussing right now, not just how we have been training machines to think in the virtual world, but how we're going to get them to act, to interact, intervene in the physical world, which I believe is so important. I've been working, my name is Nicolaus Radford. I'm the CEO of Persona AI. I've been working in humanoid robotics development for nearly my entire career. And I got my start at NASA, where we were working on building a robotic astronaut at the home of the astronauts. This went through many generations of design. We looked at how we would take our manipulators, work with people. We looked at mobile manipulation. How would we be able to put these robots on other planets? How would we get them to interact with the world around them? How could we get them to interact with the NASA astronaut corps? We got lucky enough to fly Robonaut 2, an upper body, and we flew legs on a separate space mission. I was really honored to be part of and lead the team at NASA that put this robot on the space station. We did a lot of experimentation. It was a fascinating time in my career, but more importantly, we learned so much. We actually had a partnership with the IBM Watson Group, where we started investigating the early beginnings of how we would use embodied AI at NASA. We also got to work with General Motors, looking at how we take robots into the General Assembly area. I also was fortunate enough to lead NASA's first bipedal locomoting robot, Valkyrie, which still exists today, but I also wanted to share with you a really instrumental moment where we had the world's first robot
So man meets machine aboard the International Space Station as Expedition 30 Commander Dan Burbank reaches out and shakes the hand of Robonaut.
So this was a fascinating time, and I learned so much in my career. After that, I was able to become an entrepreneur, and I was building underwater humanoids for autonomous seabed manipulation and UUVs. So let's turn our attention and set up just briefly why we're discussing this problem. We've heard a lot from the previous presentations about the changing workforce dynamics, but it's very serious. So there are some estimates from the UN that project us hitting about 9 billion people worldwide and then declining. This will be the first time ever in human history that the growth rate and our population is going to go down. Currently, we have the growth rate that's comparable to what we had in the 1600s. As we approach 2050, about 1 in 4 people in America are going to be over the age of 65. 1 in 3 is going to be that over 65 in Korea and Japan, and 1 in 6 globally. This is an enormous problem. If you couple that to the fact that the nature of work is changing, it's hard to inspire a younger generation to be welders. Everybody wants to be a YouTuber. They want to be an influencer. We're not seeing as much into the skilled trades. We're seeing a huge decline in the applications. 72% of folks find difficulty in filling these industrial jobs. We're going to see a 50% exit participation rate in the industrials vertical over the next 25 years. This is a huge problem. We're going to have about 85 million worker shortage very soon. And it's not that the work is gone. It's that we are having trouble filling and the nature of work is changing. Ergo, we're going to enter what we think is going to be one of the major and the most transformative moments in human history. The last 50 years has been characterized by the ubiquitous manipulation of the virtual world. We've had the computer age and we've conquered it. And the next 50 years will be the ubiquitous manipulation of the physical world. And we talk about robots a lot, but these are not exactly robots as you've thought of them traditionally. These are platform systems. Goldman Sachs estimates that based on the economic engines that we require and the labor disappearing, we're going to need 50 million units of humanoid labor by 2040. And platforms are an incredible idea. They're not a product in and of themselves. They create entire industry. If you look at the advent of the automobile, it wasn't just a car. It was a platform of mobility, which then gave us our infrastructure, gas stations, hotels, now that people could move around more. We had fast food, well, that's probably a bad thing that we created, but we had the fast food industry. You know, you can look at other things like the internet. The internet just wasn't this way of sharing information, but it created entire new ways of doing commerce. And I challenge us to think about the humanoid platform is not going to just be a robot. It is going to instigate entire ecosystems of economy. App stores, you name it. I'm excited for the future to see what this comes along. We can look at the iPhone as an example. Apple, in 2007, introduced the iPhone, or thereabouts. It quickly became the leader in the phone industry for over 8 quick years. It completely flipped the top 5 phone companies because Apple knew they could not compete with phones. They introduced a platform. And by 2015, there was $25 billion that came from the App Store. They didn't deliver a phone, they delivered a platform. And so now this draw our attention to the exciting work that we are doing with HD and so many of our other ecosystem partners like ABS and Basel. We are looking at how we could transform the operations of shipbuilding in the context of this physical AI, in embodied AI? What processes that we're having trouble filling in our labor pools, what might be able to be cast in the context of a humanoid robot? And one of those very important input processes is welding. And so we have embarked on an ambitious schedule. Earlier this year, we have about a 24-month timeline to deliver a welding humanoid for qualification. So we first started with what the robot was going to do. We broke that down into storyboards. We put together an animation that Chairman Chung showed earlier. It doesn't seem to want to play, but you guys have seen it anyways. And we also broke down the work. We broke down the kinematic workspace. What we noticed was the ergonomic challenges that face the human welders. We also said that this is going to be very challenging for robotic systems as well. Those became design requirements for us. And then we sent that into all the simulation work that we do. We are training our machines with human behavior. We have motion capture suits that we wear. We then send that into a massively parallel simulation of thousands of instances of the robot in simulation to learn the actions that's going to be required of it. We then orchestrate that in the context of behaviors, and we aggregate those in more and more complexity so that we can get up to the task level. So what we do is we take data from humans demonstrating this activity, and we are then able to retarget that to our simulations and run this through the reinforcement learning algorithms, really a subsection of how AI operates. And we're able to then put that into motion and develop on that. And this robot's not just replaying these actions. It's taken into account all the dynamics, the physics of the world around it. You can see that even if there's unknown objects in the terrain, that the robot can handle these objects expectedly. You'll notice the robot will step on this box. Although the box wasn't there when we trained it, the robot understands how to keep the stability. We're varying the terrain that this robot's going to encounter. We have, again, thousands of parallel simulations that are ingesting this information to create extremely robust behavior so that there will be robust real-time to uncertainty and the modalities of how the robot will ambulate. We are creating a huge data farm. Unlike how LLMs have been trained, we can't download the whole corpus of human knowledge so that we can try to infer what the next word is going to be. We actually have to generate the physical data ourselves. And so we're building out an enormous data farm with industrial manipulators so that our robot can go from primary school to secondary school to university in its actions. We have to build the reference libraries that will be put in the context of how the work is going to be done. We're also developing one of the world's best robotic hands. At the end of the day, this is a manipulation problem. We don't want the robots to just move around in their environment and look at things. We're here to actually physically intervene with the real world to do real work. That's one of the biggest demarcations between robots of yesteryear and what we're doing today. And so we've partnered with, we've licensed one of the hands from NASA, the Robonaut 2 hand, one of the robots that I showed you earlier from some of the work that we did. This is one of the best hands in the world, and we're commercializing that out for our work with HD Hyundai. The hand is exceptional in grasp. You can see Mark Kukowski from Stanford define the Kukowski grasps. And if your hand can encompass all of these different modalities, then you'll be able to manipulate common objects. And this hand was specifically designed for common tools. And so our humanoid really sets itself apart for not only being an industrial-rated humanoid, but one that can use common tools, as you might find in the context of works, especially in the shipyard. But we're also looking at the industrial design of the system. How are we going to service it? How are we going to maintain it? How would we recharge it? How are we going to swap out the batteries? How are we going to ship it? So this is not just a singular event where we're building a robot in a lab. Day one, we have been laser focused on our deployment in 2027 with HD Hyundai. And it's an aggressive schedule. We put this plan in place. We are a relatively new company, but we were fortunate enough to raise the largest amount in the world to raise the largest amount of funding in the world for a company of our stage. And we continue to bolster our balance sheet with non-trivial capital for these deployments. We are right on schedule. Chairman, we are right on schedule. We will make that delivery. And so, just to give you an idea of what we've done over the last 10 months, we went from concept to first-generation design to second-generation design to real robot to training the robot both in manipulation and locomotion. We are teaching the robot how to walk every single day. This is actually dated. I'm showing you some of our older videos, but it is fascinating. It is fascinating to watch the systems learn. It is truly just an awe-inspiring thing to watch how the robots are learning to take from what we did with training and simulation and then throw that into the real world. So we have taught our machines how to think. I think the promise of the modern AI revolution is we understand that these machines are able to do things in very sophisticated ways. But now's the time to teach them to act, which is a whole other level of problem. But we are enticed and truly excited by that challenge. I can't think of a better first market to deploy this kind of capability than in the context of the shipyard. At Persona, we are purely industrial focused right now. We're not big believers that the home is going to be an enormous market or there's other aspects. We wanted the complexity, we wanted difficulty that you find in the shipyard. This is my 4th time to Korea in the last 12 months, and I have been just awe-inspired by the sheer magnitude of the work that is being done here. So thank you once again. It was a pleasure to share this work with you all, and that concludes. Thank you.